All right. Welcome, everybody. This is our third session of this year's seminar series. I just want to briefly go with the schedule. So today we have David Abel from DeepMind. He's going to present three dogmas of RL. And then next week we have Mani, who's going to build on this work and shed evolutionary light on these dogmas. And then we're going to have Dave back the week after to talk about plasticity and empowerment and how they unify these concepts and they show that they're fundamentally in tension with each other. And then in this RL themed month of March, we're going to have the last talk. Amitai is going to tell us about the effective gradient hypothesis, which is a pretty bold claim that every behavior can be modeled as just you're maximizing some sort of affective gradient. You're going through some other affective gradients, and yeah, that's pretty much it. Then we're going to switch to theme of world modeling. So with that, I'm going to stop sharing. And before we start, Dave, do you mind telling us a little bit about your background, your career trajectory, and your research interest, and how that led to this paper?
Yeah, absolutely. So first I'll just say, thanks so much for having me. It's real thrilled to be here. I'm thrilled my co-authors, Mark and Anna, can join as well. I'll definitely get into the story of kind of how the paper came about, but just by way of background about myself, I'm a research scientist at Google DeepMind, based out of Edinburgh, Scotland in the UK, from the States originally, and have a background in a mix of philosophy and computer science. And I've always been drawn to, I think, questioning assumptions and foundations. Like I get excited by thinking deeply about our bedrock. Like, where do axioms come from? How can we try to justify one axiom set as opposed to another? How do we justify our scientific frame compared to another choice of scientific frame? And really believe in the scientific and kind of more general value of understanding learning, agents, intelligence, kind of emergent systems. I think it's one of the great frontiers of science. So for many years now, both at DeepMind and in my PhD before, focused on reinforcement learning, and really view this as a field that's trying to understand this mix of, I think, really beautiful and important concepts of agency, of learning, of reflection, the social world, cooperation, coordination. And my co-authors, Mark and Anna, I feel a deep sense of gratitude toward them. They've been just incredible folks to talk with over the years and learn from. We started a set of meetings together with effectively no agenda several years prior to this paper coming about. And we just had a running open conversation, the three of us, about whatever idea or question was captivating us at the moment. And sometimes it would be a book that one of us had recommended, and we'd think deeply about that together. Sometimes it would be a paradox or a puzzle. And these conversations over time really formed into the basis that became this paper, The Three Dogmas. The three of us worked on a paper that we'll talk about a little in the deck today. And a lot of the kind of energy from that earlier paper, I think, fueled these conversations. But ultimately, yeah, this paper was just a ton of fun to work on with Mark and Anna, and was really trying to get us to question: do we have the RL paradigm, the AI paradigm settled? Are there areas where we should poke a little bit more? And we felt these three, what we'll call the dogmas in the paper, are important areas for us to maybe think a little bit differently.
Perfect. Thank you. Yeah, so maybe let's just get started then.
Okay, brilliant. So let me bring up my slides. Just give me one moment. Okay, just to confirm, are the slides visible to folks?
Yes.
Yes. Okay, amazing. All right, so three dogmas of RL. As I mentioned, joint with Mark Ho and Anna Haratunyan. I believe, are Mark and Anna both in the call? Are you both here, just to confirm? So I'll probably lean on them at some points to.
I'm here, Dave. I don't know if
Mark's
I
here.
see him. Anna, though.
Okay. I believe Anna was hoping to join, so she may come in later. But as mentioned in the preface, yeah, I feel a deep sense of gratitude toward both Mark and Anna. This was really the end point of a lot of conversations between the three of us. So the starting point for this work is really trying to understand paradigms and whether RL and AI have kind of reached an endpoint for thinking about a paradigm. And what we mean by this is that a lot of the artifacts that come up in carrying out science, so the experiments we design, the hypotheses we form, the insights we walk away with, they're shaped in large part by the paradigms that we work with. So I like to think about this as a whole or a frame that all of our ideas, our concepts, our definitions kind of has to pass through. And the paradigm enforces this sort of structure onto the nature of the concepts and the hypotheses and the experiments that we work with. And depending on how kind of rich or narrow that paradigm is, we might end up with a relatively homogeneous and perhaps limited view of the kinds of things we can conceive of within this frame. So this has come up within the philosophy of science a number of times. So Karl Popper, one of the original thinkers in the philosophy of science, has this really beautiful anecdote that apparently during a lecture, Popper told his students, observe. And the suggestion was that observation without some kind of pre-theoretical considerations is effectively impossible. There is no just observe. We must do so with the presence of some kind of frame, some kind of theory. So Kuhn calls this the theory-ladenness of observation. This comes up as the Duum Quine thesis. So famously, Galileo, when inspecting the planetary bodies through a telescope, discovered, say, there was a satellite orbiting around, I believe it was Saturn. And apparently Cremonini, when this evidence was presented, refused to look through the telescope, arguing that the instrument itself might have introduced artifacts that produce the illusion of mountains or satellites invisible to the naked eye. So this preconception about what counts as evidence is already playing quite heavily into the kinds of experiments we can conduct and what even counts as evidence for us. So famously, right, Thomas Kuhn in this book, The Structure of Scientific Revolutions, proposed this notion of a scientific paradigm and pointed out things like the geocentric model of the solar system transitioning to a heliocentric model that's just a fundamental reshaping of how we conceive of the orbiting of planetary bodies and celestial bodies more generally, represents a new way of looking at things. It's a new set of definitions, a new set of assumptions. And what Kuhn pointed out is that this is actually one of the key ways in which progress in science takes place. So alongside, say, this geocentric to heliocentric transition, folks often point out that our understanding of germs evolving from, say, miasma theory is another example of a paradigm shift, rather than, say, a systematic accumulation of knowledge. We have to kind of radically reshape how we think about things. So when we turn to the artifacts of, say, the phenomena of agents and learning and intelligence, it's worth asking, have we finalized our paradigm? Or even what is the current paradigm? And is there room to enrich that paradigm to something that goes beyond the constraints that we might have imposed so far? So that's really the question at the core of this work, The Three Dogmas. Have we finalized what we might call an AI paradigm, or a paradigm around agents, learning, things of this sort? I know this is quite a broad audience, and I really do believe that the mixture of topics that we're all interested in can represent one of these kind of grand frontiers within science. And reinforcement learning, as Sutton says, really represents what he says is the whole AI problem in a microcosm. So it has this potential to realize, play this role of being a holistic paradigm for the science of AI. However, as mentioned with these dogmas, rather than RL having this really significant surface area with AI, we think that the dogmas are imposing this kind of constraint that perhaps constrains that overall amount of surface area that, say, the modeling and theory and definitions of RL can have with the kind of grand aspirations of the phenomena of, say, agents and intelligence and learning. And so our proposal is that it's time to surface these dogmas, reflect on whether they belong as part of our scientific paradigm, and perhaps relax them so that we can recover an appropriate view of RL as perhaps a holistic paradigm for something like AI. So what are these dogmas? Okay, so the first one we call the environment spotlight. And before I dive in, I'll just make sure to mention as well, feel free to dive in with questions, comments, challenges at any point along the talk. Really love discussion and would be very curious to hear what things resonate, what things don't resonate. So please feel free to interrupt at any point. So with that said, the first dogma we call the environment spotlight, which refers to the tendency that when we write down the RL problem, we often have these two entities, agent and environment. And our suggestion is that the environment spotlight is our natural tendency to focus on environments rather than agents. So what does this mean? Well, when we write down this loop, I would claim that at least in a lot of work, not necessarily all work, our tendency is to model the environment explicitly. So we might invoke something like this 5-tuple, this Markov decision process, or perhaps something else in this kind of rich space of classes of environments. So things like partially observable MDPs, contextual bandits, K-armed bandits, and so on. However, when we think carefully about this, what's happening on the other side of the interaction, I would claim we don't yet have a standard model of what even counts as an agent, even a simple one. And similarly, we lack that same kind of clarity around the classes of agents or families of agents that we might be interested in. By comparison with, say, environments, when we have what many might call a standard model of environments, albeit one that makes some assumptions. So maybe the state space is finite. And of course, this function R represents rewards, the goals of the agent. And of course, the Markov property is assumed to hold of the transition structure in this model. So Anna, in some earlier work, this paper, What is an Agent, pointed out that there are deep conceptual questions at the heart of thinking carefully about what constitutes an agent. And we think it's important and time for the RL community, the AI community, kind of broader communities to try to make some headway on something like a standard model for an agent. So in Tomasello's recent book, The Evolution of Agency, he closes the book with this beautiful line. Mark recommended this book to me, by the way. It was a great book. He says, every scientific discipline begins with a proper domain of first principle, as Aristotle would call it. In biology, that proper domain is life. In psychology, depending on one's theoretical predilections, that proper domain or first principle might be either behavior or mentality. But my preferred candidate would be agency, precisely because agency is the organizational framework within which both behavioral and mental processes operate. So our claim on the back of this notion from Tomasello is that agents should be among the first principles of RL too. And in large part they are, right? If we just did a word cloud of a lot of RL papers, we would probably find agents among one of the most popular terms introduced. However, we don't do the kind of careful conceptual analysis and modeling of agents that we tend to do of environments. So our proposal is just to balance this perspective a little bit. When we start with these two boxes in the RL diagram, we think it's important that we think carefully about what each of them are, and that this can open up new frontiers for the kinds of questions we might be able to ask. So one way to think about this is to reorient ourselves from an, say, environment-centric perspective to an agent-centric perspective that really just shifts our emphasis and maybe brings things into the mix, like the role that the body might play for an agent, the presence of the mind-body split. How does embodiment impact decision-making and learning in a significant way? How can we start to bring things like affordances into the fold that have some conception within MDPs, but maybe one that's more agent-centric will give us more direct footholds into studying affordances in the right way. This might change our view of goals. This might change our view of evaluations, and so on. So I'll just pause there, actually. Any questions or reactions so far?
Yeah, I had one question. Just to clarify, when you're talking about moving more towards an agent-centric approach, are you like referring to something along the lines of like an enactive approach to things, or is it more complex than that?
Yeah, great question. Yeah, thank you for the question. I would say we aren't necessarily being prescriptive about how to do this. I would say our suggestion is that there's a room to re-emphasize the agent in the mix. So there are, I think, a lot of ways to make progress on doing that in the right way. And I think others have done this. So for instance, the line of work from, say, the action perception cycle and active inference have, I think, centered the agent for a little while. Our suggestion is that there are a lot of deep and important questions about agents that we have not been able to study because we lack the basic kind of scientific apparatus and definitions and conceptual clarity in order to make progress on some of those questions. So, as one example, since I had brought it up, this question of the role that a body plays, the role of embodiment more generally, in the same way that we might have clarity on something like, say, the Bellman equation or the role of geometric discounting and thinking carefully about value or goals. Can we get that same level of clarity about what a morphology does to change an agent or a robot's decision making and learning? How exactly we do that, I think that's a room. There's lots of room for maybe research, deep research there, but that's really the suggestion. Does that answer the question?
Yeah, I think so. So it's not just like focusing on like the existing work like it spawned out from like Gibson, but kind of taking that and mathematically formalizing it better, similar to other RL equations. Is that kind of the idea?
Yeah, that's one proposal. Exactly. I'd say personally, I mean, maybe Mark or Anna have other thoughts, and I'd love to hear if they have other things to add here. From my view, I think having the MDP for RL has been enormously clarifying, and it's been unifying to allow lots of rich study to focus around this central object. And I think if we could reach similar clarity for something like a standard model for an agent, we can start to unpack some of these questions in a unified way. And of course, MDPs are not the whole story, and it's not that we need to get such a standard model right on the first go, but I think it can give us the right research affordances to let us poke at some of these new and important questions.
Yeah, I guess I would just add to what Dave has already said. Like, I mean, people have been building models of agents for a long time, like especially in cognitive science, psychology, like work on like cognitive architectures and stuff. But what's nice about MDPs is they kind of have this like they're a very general framework to think about not just one particular problem or even one particular family of problems, but like all types of problems. And you can like apply lots of algorithms on them. Is there a similar kind of standard model for agents that you can come up with? Like a space of agents that where you kind of can think about the different trade-offs between them, things like that.
Yeah, I think it's Allison here. I think it's worth mentioning that, can you hear me?
Yes, perfect.
Yeah. I think it's worth mentioning that the enacted program has been this kind of anti-representational program to a large extent. So it's been kind of hostile to the very idea of having some kind of formal representation. And I don't think there's anything in the idea that leads to that, right? That you could have a naturalistic and activist program that was like the cognitive program without, that would have the advantages of thinking about agency in that way without having the disadvantages of, waving your hands and saying, oh, well, there's some mysterious Heideggerian, agency that's involved there. And we're trying to, for what it's worth, that's one of the things that we're trying to do. But I think that would be a very good project.
Yes, absolutely. Absolutely. Yeah. Thank you, Allison.
Can I throw in one idea that may be orthogonal to what you're going to talk about? I don't know if it's useful or not, but so I went to a meeting last year. It was a lot of fun, very small group of people put on by Paul Reichers and Alec Boyd, it was about the physics of intelligence was the name of the meeting, but we wound up spending half our time talking about how do you define an agent. And what I got from it, excuse me, was sort of reinforced ideas that I got from Max Bennett's book on Brief History of Intelligence, if you're familiar with that. But the basic idea is very practical that I came from, and there was people came up with lots of different definitions. What is an agent, right? But the main thing I came away with, it was sort of an Occam's razor sort of approach. If you're trying to model something, the environment, things in the environment, yourself, all this stuff, if your model is more efficient, smaller, whatever your measure of efficiency or complexity is for your Occam's razor sort of an argument, if defining something as an agent, in terms of its goals and what it's trying to do, as opposed to the mechanism, the physical machinations, if it's easier to describe it, if your model is more effective, right? Calling that thing an agent, then call it an agent. Right? It's a very practical sort of picture. And then in Max Bennett's telling, the reason we have notions of our own hunger, goals, free will, everything else, this is coming, and that's a little maybe strong. I shouldn't put that in those words in his mouth, but that's how I read it. All that stuff comes about from some parts of the brain trying to model other parts of the brain that are doing things like reinforcement learning, and trying to account for them in a model of environment plus self. Anyway, I've talked too long, but the bottom line is it's just a practical matter of how do you efficiently model whatever the system you want. And if your system includes things that are best modeled as agents, call them agents. And I found that to be a really useful way to think about it. And I think it could account for a lot of stuff that seems mysterious in the way our brains work and how we think about stuff, and maybe useful for AI. But anyway.
Yeah, definitely. Yeah, thanks for that, Michael. I definitely resonates. I feel that's something like I guess rhymes with Bennett, the Dan Dennett view from the intentional stance to some extent. It's kind of useful to model certain things as having this sort of underlying rational mechanism that's driving them toward a goal. I'll actually come to at least an RL focused view of an agent in a moment that I think is at least, we'll come back to this in a couple of weeks in thinking about plasticity and empowerment. But all this just to say, to get at some of these questions related to agents and agency, I think it could be useful to have something like this standard model. And really one way I view this is that when we think about the existing scientific bedrocks of various fields, so for instance, set theory, arithmetic logic give us kind of bedrock concepts of the notions of true and false and negation and quantity and these sorts of things. When we think about notions of, say, belief or reasoning, we have bedrocks in probability, computation, and so on for maybe information and decisions and rationality. Maybe a parallel claim alongside what we've outlined so far is that agency doesn't necessarily have a bedrock in its own right. We kind of borrow from existing bedrocks, so things like, of course, decision theory and computation. But I want to posit that these aren't necessarily the full picture of a bedrock for agency in its own right. It's a way to cobble one together from what's already out there. But it could be the case that RL or the kind of future iterations of the paradigm of RL can give us this kind of bedrock. So there's a bunch of resources out there. I certainly won't be exhaustive, but for each of the three dogmas, I just want to highlight a few that we came across through this reading that have been particularly kind of inspirational here. So Dretsky, of course, has been thinking deeply about agency for a long time. I mentioned this Tomasello book. T. Huynh has this is again a recommendation from Mark, has this beautiful book on games, treating games as the art of agency. I mentioned Anna's paper, What is an Agent? And then Baron Dieren and colleagues have this paper on defining agency that give a very particular account of what agency looks like. There's been a recent surge in the last maybe 3 or 4 years on proposals for thinking about agents within RL. So I just wanted to highlight a couple of those. One comes from Rich Sutton, the quest for a common model of the intelligent decision maker. And I take largely what we're suggesting with this first dogma to be in line with what Sutton proposes in this paper, which is to say it's useful for us to come up with something like a common model of the intelligent decision maker. Around the same time as that paper, there's some work from Shidong, Ben Van Roy, and Zhengyan Zhao called Simple Agent Complex Environment that gives another model of how to think about agents. That's a beautiful paper. And then just from NeurIPS last year, there's this really nice paper from Alex Lewandowski and colleagues called The World is Bigger that gives a notion of an embedded perspective on agents. So I'll just leave these up for a moment in case folks are interested in looking at these, but our primary suggestion of how to move beyond Dogma 1 is to really embrace agents as a first principle within the field. And coming back to, I think it was Zachary's question, there's a lot of ways we might do this, but our view is that it's within scope for the paradigm of reinforcement learning to provide a lot of, I think, rich scientific insights and framing definitions and theory to help us better understand agents, which I think are one of these really significant kind of frontiers in science, as I've said. So I'll just give a quick take on one starting point for thinking about a definition of agent. I'm really drawn to definitions. I think those that have heard me talk in the last couple of years know I've pointed to this quote quite a few times. This is a quote from Quine. The less a science is advanced, the more its terminology rests on an uncritical assumption of mutual understanding. I love this quote, and I think it points to the need for good, clear definitions, obviously sometimes out of scope. So I think we'll likely be debating the definition of intelligence for many decades to come. Definition of agent, definition of learning. I think this space is just chock full of concepts that are quite tricky to pin down when you really dig into them. That being said, I'll just linger for just a few slides on plausible definitions of agents and just offer one quick proposal before moving on to the second dogma. The Russell and Norvig text places pretty minimal conditions on an agent. It's just a thing that can be understood as perceiving and acting. So from Michael's definition from before, this is, I think, in line with that definition, but we're here missing some notion of, say, intentionality or normativity. There's no goal seeking necessarily in this minimal view from Russell and Norvig. Dennett roughly enriches this by adding some notion of goal-directedness and perhaps adaptivity. Arguably, we could start from a minimal condition that just says a thing that can be understood as perceiving and acting, and then choose to add on top of that goal-directedness and adaptivity. So just a very quick take on this minimal definition. Well, our RL formalism effectively already coheres with the Russell and Norvig take. We're already writing down an agent as a thing that takes as input some observation and outputs some action. This, of course, leaves open, I think, very rich philosophical questions about what exactly an observation is, what exactly an action is. We'll hear punt on those. We'll defer those questions to another time and assume we have a clear picture about observation and action. And Sutton early on called this the buttons and lights model. And he says the mind is, oh, sorry, was there a question? Perhaps not. Okay, feel free to let me know if there's a question. Sorry if I missed you. The buttons and lights model just says the mind or the agent is isolated behind this interface of output bits, buttons, and input bits, lights. So this is just this minimal commitment to perception and action. And this view has been around in RL for some time. So in Mark Ring's thesis on continual RL, he proposes a version of this that roughly makes these minimal commitments. Hutter makes a similar set of commitments in his line of work from, say, Axie and the sort of view on universal AI. And then more recently in this simple agent paper by Shidong and colleagues, the same kind of view is proposed. So we might start with, say, what we call an interface. That's just the actions and observations. And these two things together can form, say, the space of experience that we'll call histories. So it's just any sequence of actions and observations together. Perhaps they don't have to alternate one after the other. Perhaps they can be arbitrary length. But this is roughly one way we can write down experience that forms from perception and action. And then an agent is just a history-based policy. It's just a mapping from any experience to a distribution over actions. This is a very functional view. This doesn't commit to any kind of internal structure, cognitive structure. So I think there's a lot of room to enrich this view. But in fact, in a paper from Russell in the 90s, this was also a proposal. They called them agent functions, which I think is at least one minimal starting point that we can hang on to and maybe take seriously as a notion of an agent. So I do think this adheres to the Russell and Norvig view, but of course, this fails to account so far for this notion of goal-directedness and adaptivity. In the Baron-Dieren work, they also point out things like the source of action and individuality. So this is talking about notions of being able to draw a boundary that separates the agent from its environment. The source of action is sort of it's the causal generator of its actions. So there's lots of room to enrich this definition. And I think, per Allison's point, like really starting to bring in some of the maybe more, if we decide it's needed, a more representational perspective on the internals of the agent as well. I won't say too much more about this, but I do think this is a reasonable starting point for getting us started and thinking about things like resource constraints. So say bounded rationality from Simon. I think there's room to sharpen this definition of an agent to capture these sorts of things. I think we can recover notions of things like definitions of learning and empowerment. And there's ways to talk about the goal directedness of these agents, even though they are just these simple history-based functions. So just to summarize Dogma 1, we think it's a useful practice going forward for us to embrace agents as a first principle. And of course, since we started writing this paper, the term agent has probably appeared like several orders of magnitude more than in the public sphere than we could have possibly imagined. So it's perhaps even more important for the scientific space to really get some clarity on this and to try to deliver some clarity and understanding about these systems that folks are building. So that's probably another good spot to pause. I'll just linger there for a moment if folks have any other questions or comments, or Mark, if there's anything you want to add here you feel like I didn't touch on, feel free to take it away.
I am a little bit curious if you have more to say on that point about Simon and bounded rationality, bounded agency, especially in relation to the comment or you highlighting embodiment earlier on as sort of one of these constellations or orbits that you're interested in.
Yeah, great question, Monty. Thanks for that. I have one proposal. It's sort of the seeds of a proposal, and this comes up in the simple agent complex environment work from Shidong and some other works from Ben Van Roy's group as well. And I have a slide on this in my backup slides, so let me see if I can okay, that worked. Can folks now see this thing that says bounded agent? Perfect. Okay, that was a slightly risky move, but it worked. It looks like. So the premise is that given one of these agent functions, we can define an equivalent object that maps histories to this object we'll call agent state, and then maps agent state to a distribution of our actions. And of course, if that first object is the identity function, so it just maps the entire history to agent state, then we fully recover this notion of pi. But we might further require this agent state space is finite. So as the history grows, this starts to impose a constraint on which histories the agent can distinguish between. And that starts to introduce at least one kind of constraint, which is a capacity or a memory constraint. And the additional requirement we'll make is that state be maintainable. So once the agent forgets something, it's gone. It can't then suddenly go back in history and recover something later on. So what this turns into is it's effectively a little finite state machine where each observation comes in and is passed through this function f, which gets to update its agent state, either by putting the observation into the agent state or not, depending on what it wants to remember. And then the agent's policy is just a function of agent state, and that outputs an action. So this view, assuming the state space can be infinite, we think is sufficiently general to capture all of those history-based policies. But as you add a constraint to the size of that state space, you restrict what can be represented from the agent's point of view. So just to say a tiny bit more about this state update function will be the previous agent state. So we have to have agents that have an S0, the previous action, if you'd like, and then the observation, and it updates the agent's internal state. We assume that this agent state space is finite, and there's an initial state that's something like a prior, but I think there's actually slightly fewer commitments on this initial state that we might impose on a prior, and then a policy that just maps states to distributions over actions. So given one of these little finite state machine agent definitions, I think there's a lot we can do, not necessarily to get an embodiment, to be honest. I don't know if this is quite there, but we can start to ask questions about what sorts of functions can be learned by an agent of a restricted state space size, even as those histories grow to be arbitrarily large.
It sounds a lot like not embodiment, but working memory. So if you have finite state space, then we can interpret that as this agent having a finite working memory, and then this connects nicely to a work from Ann Collins, where they show that if humans deviate from predictions of RL because they have finite working memory. So it's a nice connection, I think.
Oh, very cool. I'm not sure I'm familiar with it. Oh, sorry, go for it.
I was going to say, to get back to the point about the inactive point about representation. I mean, this is representation, right? This is what representation is for, is to take all of that information. And I think more than working memory, what something like a theory, for example, or a causal graph does, or a world model does, to anticipate the second half of this seminar, is to exactly give you a way of characterizing the state space that doesn't require you to keep all of the information that you've got in the past. And then I'll make a slightly motivated point, which is, if you want to, I think if empirically, if you want to try to characterize this, both looking comparatively and developmentally is a really good way to do it. So a lot of our pictures about what things like agency come from are introspection as adult humans, and that probably is not the best source of information about where these relationships come from. And if you looked at either infants or non-human animals, not to suggest that they're the same, but you might get a better picture of what the sort of foundational picture of agency is than the kind of adult introspective picture. But that's just a perhaps somewhat motivated recommendation. But I do think the idea that representation is serving this function is important. And it's a way of bridging the kind of reinforcement learning picture, which has been perceived, I think, as being quite different from the sort of classic cognitive science representational picture. Those have been in very different universes, going all the way back to operant conditioning.
Great points. Yeah, thank you, Alison. I would love, I think, if something like this could act as a bridge to bring those communities together a little bit. Absolutely.
Yeah, just to riff off of that a little bit. I mean, kind of the whole point of the environment spotlight dogma, I think we were trying to make with the environment spotlight dogma, is that it's a very behaviorist way of thinking about intelligence, that you just specify the environment and then the agent is whatever fits into it to maximize reward. Whereas, but always implicit in it is obviously there is an agent in the environment, but we just kind of treat it as a black box almost, or just we can just come up with whatever hacks we want to get it to work, and then the agent is whatever fits the environment, the optimal policy that fits the environment. And so I think part of the goal here is to kind of bring a more cognitive, representationalist like attitude towards thinking about things like MVPs and reinforcement learning.
Yeah, I guess what Allison said, representation is kind of neglected here, and you get something instead that overfits to a canned problem and doesn't really allow for it's hard to, we don't really have the conceptual foundations for something that can really learn continually or has the right inductive biases for the kinds of really subtle general structural induction that humans are able to do and is elided by current systems.
Absolutely. Yeah, I really like these points, and I definitely felt, to me, this is one of the major opportunities to kind of enrich the language of RL, to give us more of these kind of cognitive and representational pieces to just extend the scope of the paradigm, as it were. So I will bring us back. So thank you as well for letting me jump into that backup slide. I had hoped to talk about this, but I didn't want to take us too far astray unless it came up. So I'll just move on to Dogma 2. So we called Dogma 2 learning as finding a solution. And this is really inheriting I think the problem-solving perspective of a lot of earlier, say, computer science, that when we look at, say, something like chess, we tend to think of it as we model it as a game to be solved. And a lot of the traditional RL benchmarks, things like Breakout or Mountain Car, Montezuma's Revenge, they're tasks, finite tasks that have some fixed endpoint at which we consider the task solved. And one way to think about this is to define imagine we have a policy space, a space of candidate solutions that we're searching over. And we view the search process as something finite, so that eventually our learning curve will level off when the learning algorithm has found this desired solution within this solution space. And this is really this view of learning as solving, that we're interested in these small, doesn't have to be small, but say tasks that have a solution, and we'd like RL algorithms to deliver a solution to those tasks. And continual RL historically has been placing the emphasis somewhere else. And of course, this appears under many names. There's lifelong learning, there's never-ending learning, transfer learning, multitask learning. I'm not going to differentiate too much between these. To me, they're broadly after the same kind of distinction. Even things like, I'd say, open-endedness are trying to capture the distinction between learning to solve a task and treating learning as something more like adaptation. And I think this perspective is actually even present directly in the Sutton and Bartow book. So they say in the early chapters, when we say that a reinforcement learning agent's goal is to maximize a numerical reward signal, we of course are not insisting that the agent has to actually achieve the goal of maximum reward. Trying to maximize a quantity does not mean that that quantity is ever maximized. The point is that a reinforcement learning agent is always trying to increase the amount of reward it receives. So I think this very notion of learning as kind of continual improvement or adaptation is present in the original, the Sutton and Bartow book. However, I do think
sorry to interrupt, but actually, it's not in the 2018 version. I looked for this quote when I read this paper originally, and it's only in the 2015 draft version of the second edition. So, yeah.
Is that right?
That's right. Yeah. I checked in my everyone checking your Sutton and Bartow's.
Okay. I thought I had quoted this from the first edition of the book, actually, but I could be wrong. But that'd be interesting if it was taken out. Well, I'll just say then, the draft edition, the spirit of this point was present within Sutton and Bartow, but I do wonder why they took it out. That's interesting. Thanks for that, Henley. One way of making this distinction, which is another excellent book that Mark recommended to me, comes from this book, James Carse, Finite and Infinite Games. The very first line of this book is that there are two kinds of games. One could be called finite, the other infinite. A finite game is played for the purpose of winning, an infinite game for the purpose of continuing the play. So when we think about this second dogma, we're suggesting that a lot of reinforcement learning has historically focused on finite games rather than infinite games. So our suggestion is to study the infinite game, to truly treat learning as adaptation. And of course, I think to a community like this with such a broad perspective, I imagine learning as solving is maybe not the default view anyway. But I do think that treating learning as something more like adaptation has the potential to take us to new frontiers that maybe haven't been seen in RL previously.
So speak of definitions, can you define adaptation?
Let me take a crack at it.
Yeah.
I'll give 4 candidate definitions for learning.
Mm-hmm.
And I would say for my full story, this will come up in the plasticity as the mirror of empowerment work in 2 weeks.
Mm-hmm.
But yes, famously difficult term to define. Absolutely. At the very least, I can give this kind of 4 category taxonomy for ways to think about learning, or say adaptivity. The first is a mechanistic view that would attribute learning to the presence of a special elevated mechanism within an organism or agent that we'd say is indicative of learning taking place. So I'd say on the machine learning side, some people would say, we're computing gradients. therefore learning is happening, or something like this. Of course, in context learning has changed this story quite a lot since I maybe first created this slide. However, I do think that this is at least one view, the mechanistic view. The second is a purely behaviorist view that says learning is a meaningful change in behavior due to experience. So we'd put an organism or an agent in a variety of different circumstances and ask, is the behavior of this organism changing meaningfully in response to these different experiences? The third is the view from, say, uncertainty or knowledge, which is that uncertainty is reduced over time. It's a sort of a Bayesian perspective, or there's more of a knowledge-focused view that says knowledge has been acquired over time. It's a bit of a risky move to defer the definition of learning to a definition of knowledge, however, I think, which is also, of course, famously difficult to define. And the last view, which is I think the most classical machine learning view, this comes from really the Mitchell textbook, as well. Lotfi has this early paper on the definition of adaptivity from the 60s, and this is the one he sort of points to, which is to say learning takes place on a task when an agent's performance on that task has improved. So this is really the Mitchell definition that's more machine learning focused. However, I think all four of these are really, they're different camps in some sense. They often overlap, they often intermix. They're really, I think, to me, pointing to one of these cases of the sages poking at an elephant, that we have this kind of fundamental concept like learning, and we have these variety of lenses on this concept. But it's not obvious we've really identified which are the symptoms and which are the essence quite yet. So for more on that, I'll give a maybe deeper dive on notions of adaptivity in 2 weeks when talking about plasticity. But zooming out, I would say the main premise is to move beyond. We can still, of course, focus on learning as solving in some cases when it's needed. But I think a more general notion is something like learning as adaptation that allows us to embrace the infinite game. So I'll again just highlight a couple papers in this space that I have found illuminating in working in continual RL. There's a ton of great work in this space. Of course, I could spend the whole session just talking about summarizing this work, but I'll just highlight. So Mark Ring's thesis in the 90s was really the first to study continual reinforcement learning specifically. Kimia Ketterpal and colleagues have this really wonderful survey on continual RL from a few years back. And then recently, Saurabh Kumar and colleagues wrote this paper on continual learning as computationally constrained RL that takes in, coming back to Simon's bounded rationality, takes computational constraints as a key piece of thinking about continual learning. And then myself with some colleagues, we have a proposal for a way to define continual RL that really takes a purely behaviorist perspective. Okay, so before I move on to the final dogma, I'm curious if there's any lingering questions or challenges or anything of that sort before we press forward.
There's this notion of adaptation. Yeah, so because of my own background, I have a little biased view of defining adaptation as adapting to the statistics of your environment. So this goes back to theoretical neuroscience, Horace Barlow's work. And the idea is that amazingly living animals, they always adapt to the statistics of their environments across time scales, evolutionary time scales, down to moment time scales. And then if you just try to mathematically formulate that, it looks a lot like maybe something like a cross entropy term where has like generative modeling kind of flavor. I wonder if that fits your...
How do you mean adapt to the statistics of their environment in this case? Because on evolutionary timescales, that becomes tautological. Fish aren't found out of water because they'd be dead. Except the ones that
let me give you a
found
concrete
out of
example.
water and became reptiles.
Okay, so let me give you a concrete example in this evolutionary timescale. We know that the statistics of natural scenes contains more cardinal orientations, vertical or horizontal, as opposed to oblique. And we find in the visual cortex, we find that the neurons that are selective for these cardinal edges are more numerous. So this is something that you find in the organization of the visual cortex that captures something real about the statistics of the environment. So I wonder if that definition of adaptation fits any of those four categories that you mentioned earlier, Dave?
I think of this as being a behaviorist perspective insofar as if you're looking at whether the statistics of the environment are being adapted to in terms of the behavior changing relative to those statistics. If it's more of a cognitive faculty that somehow statistics of the environment are making an imprint on the organism's mind, I would put that more in the mechanistic category.
I think it's the latter. Yeah, it's just the representations reflect something about the statistics of the data that you've adapted to across timescales.
Got it. Yeah, I would put that as the mechanistic category. Like, say your beliefs are imprinted as a function of the statistics of the environment or something of that sort. And that certainly has quite a lot of. So let me pull that. Oop, wrong button. Sorry about that. Can you still see the slides?
Mm-hmm.
Yes. Okay. Good. That's always a risk. Yeah. So there's this set of papers that go back and forth debating whether or not like a cognitive change or behavioral change is sort of the most salient part of adaptive behavior. Well, of being adaptive, I should say. For our purposes, I'll just give a quick teaser on my view from this plasticity work coming in 2 weeks. We effectively agree with the view you're describing, and we'll say we model in terms of influence. So can the data that the organism receives influence either the content of the agent's mind, so that agent state we looked at, or the agent's behavior? And if either of them is true, then I'd say adaptivity is present, or at least plasticity is present. There's maybe some room to draw a distinction between those that I think matters, but maybe for our purposes today, the subtlety is not so crucial.
Perfect.
In terms of what it seems like there's another model, and I'm wondering if you're just thinking of this as being in the uncertainty category, which is a sort of inverse problem solution model, which is what you get from something like vision science or signal detection theory, where the assumption is there's something about not the statistics, but the structure of the environment, what the environment is really like. The agent's getting a sample from that's been generated by that structure. And then the problem is, how do you recover what the actual structure is? And that's kind of like the fundamental paradigm for vision science, for example. I think both certainly in psychology and neuroscience, and to some extent in computer vision as well. And I'm not quite sure where that would, and that's the paradigm for philosophy of science, I think, as well, and for cognitive development. And I'm wondering where that would fit in your picture.
Inference.
Yeah. I would put this in this third category. Exactly. I think I'm being a little too narrow with this term uncertainty, but I think this is collectively intended to refer to acquisition of knowledge about the environment. But I found the term uncertainty had lighter commitments than using knowledge here. But
Okay.
Based on what you described, I would put that there. If you feel comfortable with that, then I'm happy. But I'm happy to talk more too.
Yeah, I mean, I think the Bayesian approach, I mean, is clearly an instance of trying to solve the inverse problem in a particular way. But I think there probably are other ways that you can solve it that aren't necessarily rooted in a Bayesian perspective, or in terms of thinking about uncertainty. Because, for example, when it's funny, David, because when you mention the examples of paradigm change, right? Paradigm change isn't about, oh, now I've got a higher probability for this hypothesis than the previous one, right? That's about, oh, now I've got a structural framework that it's closer to what I think the world is actually like than the one that I had before, even if the probabilities actually aren't gonna, notoriously, the probabilities are not necessarily going to change if you have an epicycle view versus a Copernican view about how the world works. So there's some other constraint that's involved there.
Yeah, good point. Definitely. Yeah, we kind of don't accommodate the paradigm within this view of learning somehow at the moment, which is a problem, certainly.
And it's worth, this is my thing, but it's worth mentioning that this isn't just about fancy scientific learning. This is true about 3 and 4-year-olds too, that they're going through something like a theory change or a paradigm shift, and that seems to be a really important part of how they're learning. But I will stop there.
Absolutely. Yeah. Thank you, Alison. All right. So unless there's any final comments on Dogma 2, I will press forward onto the reward hypothesis, which is probably where there's the most opportunity to dig in deep if we want to. But I'm mindful of time. My understanding is we still have an hour. Is that right, Hadi?
Yes. Officially, we're going to end in 1 hour, but depending on your availability, we might also linger for questions. Up to you.
Okay. Sounds good. Okay, no worries. Thanks so much for stopping by, Mark. Appreciate it.
Thanks, Mark.
Thanks, everyone.
I'm also mindful we've been sitting for an hour. If folks need just a minute to stand up and stretch, no worries. I'll just get a quick drink of water while folks do that, and then we can. Okay, so onward to the reward hypothesis. So I think we chose the term dogma for this paper as an homage to Two Dogmas of Empiricism by Quine. And as part of writing the paper, we felt dogma was potentially too strong for really what was going on in the RL community. Now, I would say of the three, to me, the reward hypothesis maybe feels the least dogmatic, in part because the name hypothesis appears directly in its statement. It's not intended to be a dogma. It's intended to be a hypothesis about how we understand goals, how we understand purpose. And I think it's already played a really illuminating and productive role in the community. But that being said, of course, when we study reinforcement learning, the form of reinforcement that we're familiar with are scalar rewards. And so we did find it was important to kind of unearth this hypothesis and inspect it a little bit. And Mark, Anna, and I, along with some other folks, the reason we originally started this line of work was back in 2020. It was just about a couple weeks before the pandemic. Mark and I were grabbing a dinner together and started talking about the reward hypothesis, and we thought, gosh, we should try to dig into this a little bit. And this line of work grew in part from that initial conversation. So I'm primarily going to summarize a paper called Settling the Reward Hypothesis that Mike Bowling and John Martin led, that I helped with my colleague, Will Dabney. And in this paper, the goal is to translate the natural language statement of the reward hypothesis into a formal conjecture, and then identify the conditions under which the conjecture is true. Now, this doesn't necessarily fully settle the reward hypothesis, of course. There's room to disagree with our interpretation. There's room to disagree with the assumptions, but we wanted to lay out one complete story that turns the reward hypothesis into a true or false question. So that's where we end up. The reward hypothesis, first stated by Sutton, and as far as I'm aware, I heard Sutton mention this at an RLDM in Montreal. He attributed it to Michael Littman, and I believe Michael Littman attributes it to Sutton. So unsure of the true genesis, but the one I'm most familiar with is from Sutton's website. It's this quote here. It says, "All of what we mean by goals and purposes can be well thought of as maximization of the expected value of the cumulative sum of a received scalar signal, reward." Now, my first reading of this, and my lingering reading in many ways, there's some places I might disagree, is to imagine that we start with something like a goal space. So we have some goal designer that we'll call Alice, and Alice has a space of goals in her mind. And what the reward hypothesis could mean is that Alice, given any goal in her mind, can turn that goal into a reward function that, given some experience from the environment, will produce signal to a learning agent, Bob, such that when Bob maximizes that signal, Bob can output a solution to that achieves this goal that Alice had in mind. And just to simplify the hypothesis, what that means is we think all goals, no matter what goal space Alice starts with, she can always write it down as a reward signal that can be maximized. And in this work, Settling the Reward Hypothesis, we really want to ask, is this hypothesis true? Is it false? When is it true? Why is it true? And we'll build toward one single result that reveals the conditions under which the hypothesis is true. And Mike Bowling had a really nice way of laying this out. He said, we should think about this in terms of a series of doors of two kinds. The first set of doors will be the framing assumptions. These are going to be ways we interpret the natural language of the reward hypothesis to give us a conjecture. And then once we have our conjecture, the second set of doors are the formal requirements for that conjecture to be true. And a quick teaser of what those formal requirements will be. They're roughly going to be the von Neumann-Morgenstern axioms plus one extra axiom. But getting all of this off the ground will take a little bit of extra machinery. So I'll just introduce a little bit of notation. This will feel similar to the notation from our discussion of agents previously. So we start from this interface that we defined before, an action space and an observation space. These are two, we can think of them as finite sets. They can be countable, but we'll just suppose they're finite for now. These will give us the sequences of experience that we'll call H, or for history. And this is going to live in this set mathcal H, which is any set of any sequence of action observation alternating. Now, this defines a particular class of environment. This was first studied by Marcus Hutter in his line of work on, again, universal AI, sometimes called general reinforcement learning. This is a history-based environment. So it's effectively an infinite state POM-DP, but it's deprioritizing the role that the environment state plays. It's kind of obscured from the agent's view. So there were times in various lines of work where we defined these environments that I wanted to call them an aperture, because it's really more of an agent's look into an environment. And I'm using this delta O notation to refer to the probability simplex over O, meaning this can be stochastic. So given any body of experience so far and the agent's last action, the environment will sample from some observation space and then give that observation to the agent. And this environment class, it's worth pointing out, we can, of course, capture something like a Markov process with this, where the environment just ignores all of the history except for the last observation and the agent's action. We can capture POM-DPs with this as well, where there's some complex state space transition happening under the hood, but only this sampling process is directly visible to the agent. And the agent, as mentioned before, or the policy, we're just going to define as this history-based function. So given any body of experience so far, the policy is going to output, again, a distribution on actions. Now, since we're talking about reward, we'll need to introduce a little bit of notation for this space to focus on rewards. We'll focus on what we'll call Markov rewards, which in this setting is just a function of the last action and the last observation, and we assume can output a real number. We'll also generalize the discount factor to also be a function of experience. This will give us some extra leverage in what's to come. However, if you want to capture the traditional discount factor, you can, of course, just ensure that gamma for any input A and O is just outputting the same exact value. So you could just say, well, it has to be 0.9 for every action and observation, and therefore you recover this constant discount. And our value function, it's going to look like a lot of mess, but this is effectively the same notion as our traditional value. So we still have an expectation, but now it's over a choice of this history-based policy and history-based environment. We still have an accumulation, but it's over a finite length of experience n, which we'll come back to in a moment. This big product in the middle is just accounting for all the discounts. Usually that would just collapse to gamma to the, in this case, I guess, I minus 1. And then we have a reward, which is, again, Markov. So it's a function of A and O. And these are all random variables because both the environments and the policy can be stochastic. So this is going to be our notion of value. And again, it's relative to a given fixed n, which we'll come back to in a moment. So any questions on the notation first before I move into the first two of our 7 doors? Great. Okay. Feel free to stop me if you have any questions on this. So our first 2 doors that we'll set up for ourselves, and the reason I think we think of them as doors, this is again coming from Mike Bowling, the lead on this. These are chances to walk away, effectively. You're allowed to disagree with the reward hypothesis in a number of ways, and we're trying to identify the doors through which you can walk that allow you to disagree with the reward hypothesis. But if you don't walk through any of the doors, then you must agree with the reward hypothesis on our view. So these are the 7 doors. So the first 2, how do we turn that natural language statement into a formal conjecture? So again, this is the natural language statement. And really the first door is going to be addressing, well, if rewards aren't goals or purposes, what is a goal and purpose? If rewards are not communicating are not themselves the actual goal, they need to be communicating something about the goal. That's what it would mean for rewards to be effectively expressing a goal or purpose. So we adopt the view that a goal or purpose is a preference on outcomes. So as an example, classic example from decision theory, if you have an orange and you have an apple, you might say, I prefer the orange to the apple. And this is captured by this preference relation here. We can, of course, enrich this notion and capture something more like a bandit, where we have, say, a menu of different options. We might say, prefer the salad to the sandwich. We can apply preferences to RL, so things like Markov decision processes when we have states, where we have, say, two states of a chessboard, and we might prefer one state to the other. But in the most general case, we just have histories of experience, and we can ask the question, do we prefer history H or history HH prime? Which one do we prefer? So this preference relation is going to be our first notion of our first door. It's a goal or purpose is well understood as some kind of preference relation on these histories, on these experiences.
Can you clarify if this is a consensus in the field, or is this your proposal to define goals and purposes?
Oh, that's a great question. So I can say there's a philosopher, Ruth Chang, who has argued against elements of this.
Mhm.
I actually was just speaking with her in the last couple months about this, and I definitely don't want to put words in her mouth, but my best attempt to articulate her view would be, well, she says a couple things. The first is that certain kinds of preferences we should do away with entirely. That'll come up actually in a few slides, specifically her work on this. The other thing she'll say is that it's not obvious that preferences as a kind of mathematical language forefront the right sorts of considerations for us when thinking about goals. So I'm pretty sympathetic to that. So I would say she's the one I'm most familiar with that has developed arguments against this. I wouldn't say this is a consensus view, though. Certainly, that's a great question. The thing I struggle with a little bit is if you don't adopt preferences, there's a question of what else are you going to adopt, and where specifically does it end up departing from preferences? Because to me, preferences, without any other assumptions about the preference, all you're saying is that there is some space. It could be experience, it could be cognitive states, it could be policies, and you have some mechanism for comparing them. That's a pretty light touch. So I think if you disagree with preferences, I think you need to disagree with that view, and that feels like, to me, is a very light view. I'm open to entertaining other options, of course. But of course, there are other ways of conceiving of goals and purposes, but oftentimes they can be translated into preferences just because preferences are so general. But if they do have a weakness, I think it's really to Cheng's point that they might not be the right sort of mathematical language for forefronting the right sorts of considerations, even if they are expressive enough to do so. Yeah, great question though, Hadi. Thank you. I'm curious, is there anyone on the call that would be bold enough to offer would folks feel willing, if you feel, is there an argument you have in mind for maybe not embracing preferences, at least one plausible view of goals? If not, we can always happy to talk offline too. Feel free to shoot me an email. I find this a really interesting question.
Just preferences in the sense of a partial order?
A partial order would be one instance of a preference. That's right. One family of preferences. Yeah.
Sorry, just a question. You did cite a couple of philosophers in your paper, and I think Cheng was one of them. And I'm just wondering, one mentioned, or like, if I remember correctly, one of the core sort of points of opposition towards this framing was this issue of incommensurability, if I remember correctly. Like, was this Cheng, or is that?
Exactly. Yes.
Okay. So yeah, I suppose for me that was like the main thing that stood out as not necessarily offering an alternative to this view, but I felt like whatever alternative we do come to sort of has to confront that issue of incommensurability.
Yeah,
I mean, this is
definitely.
the Isaiah Berlin picture, right? Where you say, no, it's not that you are balancing these preferences between, your obligations to others, and the classic example is the Gauguin is leaving his wife and kids so that he can go off and pursue exploration. And the idea is it just isn't any way of putting those goals in a preference format. There isn't any way of saying, yeah, if you have more of this one, then it's better than the other one. That's Isaiah Berlin's basic life tragedy. I think Cheng's argument might be something like that, but that's the
Exactly.
incommensurability argument.
Yeah, absolutely. So I would say my personal take on preferences is that there's a softer category of preferences that does away with incommensurability and says, look, it's perfectly plausible to have experiences that just cannot be compared. And our preference relations can only bear on, say, related categories. So you can talk about which fruits you prefer, but you can't talk about whether you prefer fruit or a hike. They're just fundamentally different experiences. And that's a category of preference that does away with incommensurability. There was another, we'll come to pieces of this, but there's another argument from Aumann that argues against one of these five properties called completeness that is trying to get at some of this machinery. So I do think preferences do give us a language for talking about different degrees of commitment to what has to go into our account of goals. And that's a reason that I'm drawn to them as a language, as a modeling tool, because we can pinpoint some of these distinctions and say, you want to embrace incommensurability. Well, it means you don't have to bring on board this property of your preference, and say, instead of having a total order, you have a partial order or something like that. Yeah.
Dave, just to give the empowerment defense, I would say that preferences could be considered downstream or secondary to some other form of value judgment, because relative empowerment, for instance, can induce a preference relation. But the problem with preference relations is if you're an open-ended agent, there has to be a reason for them or something like that, I would say.
Right. Yeah. Thanks, Tom. So you'd say, in that sense, empowerment is sort of primary and preferences can live on top of them because empowerment gives the preference a reason.
Right.
Yeah, I mean, this would be the picture that says you want to get the representation of the environment, because it's only when you've actually got a representation of the environment that your preferences can make any sense, right? So if you don't actually understand what the environment is like, if you don't understand what will happen as a result of your actions, what the outcomes are going to be, what the relationships are, then you're not going to be able to have a set of preferences that make sense. But I think there's another interesting piece, and I'm not sure what I think about this, which is there's an argument that having a kind of division of labor, this is something that's come up in the kind of multi-agent world, it means that to solve certain kinds of problems, you have to have a division of labor, exactly because you can't have a single agent that has a single set of preferences. That you do better if you actually have multiple agents, either sort of internal to the person or across people who have different sets of preferences that will somehow lead you to a coordination metric that will be better overall, and that you couldn't just have that by instantiating it in a single agent at a single time. I think that's another kind of objection. So even if you think about explore exploit, right, that, which is kind of what we were talking about when we were talking about empowerment being the basic, a more basic kind of goal. It's a real question about if you're literally, if you're thinking about a 2-year-old, your exploration could lead to the death of the agent, right? You know, if you're exploring by putting the stick into the plug, right? That's going to end up with no agency at all. And yet you might think, oh no, but it's actually good to have agents out in the world who are doing things like that, because in the long run it's gonna be helpful for coordination. But of course the question is, how long is that long run of continual learning?
Oh yes, such good points. Thank you. There's a couple things in there I want to respond to, but I'll restrict myself to one just for time. So the first piece on structural learning of the world coming first, and then preferences coming second on top of that. There was a thread in this exact line of work on this reward hypothesis. We had this earlier paper with Mark and Anna and some other folks, where we consistently had to question the order in which objects were introduced. In that work, we said the environment exists. So we're given, in that case, a Markov process. We had something like an MDP. Then we get preferences, and then we get rewards. And one thing we found was that sequence of environment, preferences, rewards, we could find preferences over that specific environment that dealt with impossible outcomes for which reward couldn't do anything meaningful for the agent, because it never actually experienced them. So in other words, the agent could never form valid preferences over impossible outcomes through rewards, because it needed to experience the rewards to learn about those impossible outcomes. Now, in this work, we ended up making the exact opposite choice, that preferences come first, and then the environment imposes constraints on what's possible. But it's perfectly valid here for agents to have preferences over impossible outcomes. So I just found this thread you mentioned so interesting about both you and Tom, this point, learning about the structure of the world, learning about an agent's empowerment or empowerment gain as being a possible kind of motivator for the genesis of preferences. Anyway, I love this thread. It would be great to talk more. I haven't thought too much about the multi-agent case, to be honest, but I find that set of considerations also feels like it just opens things up in a really rich way that I don't yet know how to think about. Okay, so I will press on with the second of our two interpretive doors. So the first will now assume, so thank you as well to Mani for asking that question. Yeah, really great question. Love that question. So the first door was that we'll understand goals and purposes in terms of preferences on outcomes. And the second door is really digging into this language of well thought of. So what could we mean when we say that goals and purposes are well thought of in terms of reward? What is that? How do we connect these two objects? And this one takes a little bit of work to dig through, but I want to go through it with you all, because this ended up being, I would say, probably the most challenging piece of this work, one of them, to make sure that we had done this in a way that felt satisfying and as simple as possible. But it's really about the question, how do we connect preferences on outcomes with rewards? What does it mean to minimally bring those two things together? And of course, there's the rich landscape of decision theory that has thought through, say, utilities and preferences. But within reinforcement learning, we just have a few extra pieces to consider. So we want to make sure we're doing this in a way that really respects the groundwork that the decision theorists have done, while also respecting the key formalisms for reinforcement learning. Okay, so what this means for us, this well thought of, is that what the well thought of translate to is that preferences can be conveyed through rewards. How do we get at this using the tools we've introduced so far? And this will start to look like our formal conjecture. We say for all preference relations, and again, so far we haven't imposed any requirements on this preference relation. It's just a thing that, given some space of outcomes. So say bowls, fruits in a bowl, you just have some way of comparing them, but you can always abstain. You could say, I just am incapable of comparing apples and oranges. It's not that I think they're equal. I just think they're fundamentally different. And that's perfectly allowed so far. So for all preference relations, there exists a reward function discount pair such that the outcomes induced by one policy compared to the other cohere with the value that we assign to those two policies. So if we prefer one policy, so here the orange hiker, we better also assign more value to that policy than we do to the purple. And we had this notion before of a policy value. This was this VN we introduced, but we have not yet talked about policy outcomes. So we'll need to define both of these two blocks in a little bit more detail. So policy outcomes really refer to, given a policy, what is the distribution of experience that they induce? So we'll define this using this object dn of pi, which places a probability over histories of length n given that policy in that environment. So if both environment and policy are deterministic, then you end up with a Dirac on a single history. But of course, in most environments and most policies, this is going to be this relatively messy distribution. So we end up with this whole spread at time n. What we'll end up doing is varying over n, but just for now, these objects of dn pi are now distributions over outcomes themselves. They're no longer policies. So what this lets us do is say, rather than talk about, do I prefer the orange policy or the purple policy, we can now just ask, do I prefer the distribution of outcomes from the orange policy compared to the distribution of outcomes from the purple policy? And now that we're talking about policies, we again can talk directly about value. So if we're only focused on a single point in time, we can ask the question, if I prefer the distribution of outcomes at time step n from policy 1 to policy 2, do my values for policy 1 to policy 2, or is it also greater at time step n? So I claim that with the ingredients we've introduced so far, these two boxes are both well-defined, and we can actually ask this question, when the left box holds, does it entail that the right box holds, and vice versa? Now, this is all for one fixed length n. So what we need is to now range over all possible histories in some way, or something like all possible histories. And the way we'll do this is to suppose there is something like a finite horizon, after which we'll assume that this equivalence holds indefinitely. So what this means is that before this large n, our preferences between the two policies can oscillate arbitrarily. So we could say, well, the orange policy is learning really quickly at the beginning. The purple policy is sort of biding its time, but then it catches up and it does a really good job later. That's all fine. We can oscillate our preferences, but there must exist a point in time after which one policy is strictly preferred to the other, if and only if its value is greater than or equal to that of the other policy. So this piece, I would say, was among the trickiest to work out. To give you a sense of why this piece was so troublesome, we kept running into these issues like, well, what if I prefer odd length trajectories to even length trajectories? How can we accommodate this notion of contrasting experiences of different kinds? And there are many different ways we could imagine connecting policy to policy preferences to value. And this we felt was the cleanest. So this gives us the following conjecture. For all preference relations, again, over these really distributions of histories, there exists a reward discount pair such that we prefer a policy, pi 1 to pi 2, if and only if the value of pi 1 is greater than or equal to pi 2. So that is effectively the conjecture. We're missing the quantifier over these two quantifiers to ensure we get this strict domination of one policy over the other after a certain point in time. That's included in this full form. But again, the key thing is this resonance between preference on policy outcomes and policy value. So those are our first two doors. We claim this is now a formalism for the reward hypothesis. This focuses on Markov reward. I can point that out, given that we're not looking at history-based rewards. However, we are looking at what we take to be among the most general classes of both environments and policies, since we're looking at these history-based functions. So we will recover results for PUMDPs and MDPs as special cases. Okay, any questions here before
Is this simple? Can we simply describe this conjecture as the idea that there exists a scalar valued function that we can map any policy to? So we can compare them.
It's a little stronger than that. It's almost that. It's saying there's a scalar value function that places an ordering over my policies that matches my preference on the outcomes induced by those policies. So one way you could look at it, it's an if and only if, but let's start from the preference side. Suppose we didn't think about policies at all to begin with. We just looked out at the world and said, well, gosh, I'd really like, let's say, apples more than oranges. So any distribution, and let's say the world is deterministic, any experience with more apples than oranges is better. And then we go and look at policies and we say, well, now how do we assign rewards to policies such that we'll only give these one policy more reward total in expectation if it yields outcomes where there's more apples than oranges? So it's asking which preferences can be captured by an ordering over policies. And it turns out there will be further restrictions required. This conjecture, as stated, is false. And I think that'll become clear in a couple slides, because we haven't yet added these things like the, right now, this kind of is in line, in my view, with Chang's take on incommensurability, because we're not insisting that all histories be comparable necessarily. Yeah. Thanks, Hadi. Great question.
Thanks.
Any other questions here? Perfect. Okay, let's press forward. So we'll now move into the second half of the doors, which are those that specify further conditions on this conjecture for it to be true. So I'll just point out that as per Hadi's question, this very start of the conjecture, it's a universal quantifier, right? We're saying for all preference relations. And there are just really weird preference relations that exist in this space. So as an example, we can violate transitivity. By default, there's nothing about the definition of a preference relation on its own that says it has to be transitive. So for instance, you could say, I prefer an orange to an apple, I prefer an apple to grapes, and I prefer grapes to an orange. That's a valid preference relation. It's a weird one, but we haven't yet ruled that out. So in order to rule that out, what we'll need are these extra doors that impose these additional constraints on the preference relation. Now, as I mentioned earlier on, these constraints are effectively going to be what are called the von Neumann-Morgenstern axioms. There are a couple ways to give axioms for the foundations of decision theory. Von Neumann-Morgenstern is kind of one of the, I would say, effectively the most standard. And just as a fun piece of history that I learned about in doing this work, long before the reward hypothesis, there was a thing called the expected utility hypothesis, proposed by, oh gosh, am I going to forget? I believe it was one of the Bernoullis. I'm going to forget. I'm sorry. I shouldn't name the name. But it was from, I think, the late
Ramsey, maybe one of those people.
It was long before them, actually. It was
okay.
It was in the 1700s, I want to say, that this problem first came about.
Daniel Bernoulli.
It was a Bernoulli. Thank you, Henley. I appreciate that.
Wow.
Okay. But then, yes, as you said, Hadi, so Savage and Ramsey did a lot of kind of deep foundational work on decision theory around this same era. But the expected utility hypothesis was asking, should we maximize expected utility? And there's, of course, a lot of resonance between expected utility and what's posed in the reward hypothesis. So we effectively onboard the four von Neumann-Morgenstern axioms. I'll just go through what they are at a slightly high level, but then we'll go into a little more detail shortly. So the first axiom is called completeness, which says that the preference relation has to have a genuine preference between every outcome pair. So this is where Chang's incommensurability comes in. You have to be able to compare, walks on the beach with biting an apple. They're just fundamentally, your preference relation must have some outcome for them. Whereas a default preference relation, there's an option to abstain from comparison. The second axiom is transitivity, which rules out things like cycles that we talked about on the slide or two ago. The third axiom, independence of irrelevant alternatives, says that independent alternatives can't change your preference. We'll dig into that one in a moment or two, because that one does a lot of work to rule out things like constrained objectives and risk-sensitive objectives. The fourth is continuity, which says there's always a break-even chance. And these four collectively characterize the von Neumann and Morgenstern axioms. Now, as mentioned, we're interested in Markov reward. If we only cared about history-based rewards, these four axioms are in fact sufficient to prove the conjecture. And they actually fully characterize the preferences that can capture history-based rewards. However, for us, Markov rewards play this very special role within reinforcement learning. So we really wanted to understand what additional condition is necessary in order for Markov rewards to be the sort of unique answer to this question. And for that, we identified a fifth condition we call temporal gamma indifference, which says roughly that discounting is consistent through time. I'll say a little bit more about these three and then skip out on axiom 2 and 4. So completeness says, as we've talked about, that we can contrast any two experiences. So if we look at some history at the beginning of time and then a history h prime far into the future, we can compare them. And what Aumann argues in this paper is that this is perhaps an unrealistic burden to place on people, that we just don't have a genuine preference between every possible experience. And then as mentioned, Ruth Chang, sorry, that's a typo, has this really lovely paper on value incomparability and incommensurability that talks deeply about really a lot of this comes from the sort of virtue ethics perspective, that virtues are just fundamentally incommensurable. You can't contrast sort of mercy with justice. They're just not of the same unit. So the independence axiom says independent alternatives can't change your preference. What this means is that in comparing, say if you said, I prefer an orange to an apple, if you satisfy the independence axiom, it means that if you have a chance of an orange, you must also prefer that to the same chance of getting an apple. In other words, the chance of something can't suddenly vary your preference. So independence is what rules out risk sensitivity and constraints, as I mentioned, precisely because it takes into account the chance of things happening. So a lot of the paradoxes that come about in, say, behavioral economics, so-called paradoxes, where people have certain kinds of risk profiles that don't quite capture, that aren't reflected in kind of the standard von Neumann-Morgenstern axioms, are often violating this axiom. Because depending on the chance of something, people's preferences do often, in fact, change. So the new axiom that we introduced essentially requires that if you have two experiences and one is preferred to the other, so H is preferred to H prime, there can be kind of a magnitude at which you prefer H to H prime. I can say a little bit more about that in a moment. But what this means is that if I prepend some experience, AO, so a single interaction, I act and I get one observation, then I must prefer AO H to AO H prime with proportion gamma times kappa. And the way in which you can get this kind of kappa notion is that from the other axioms, you can effectively talk about ways of mixing together lotteries to create something like a notion of the amount that you prefer one thing to another. So this is the reason that we go in for this gamma as a function of A and O. And in fact, this means that there are some preference relations that can only be captured by a gamma that depends on being able to take as input A and O rather than a constant. So all of that lets us then turn that conjecture into a theorem that says a preference relation satisfies those 5 axioms if and only if there's a reward function such that these properties are satisfied. So the if and only if I want to linger on for a moment, because it means that if we write down a reward function, we're implicitly talking about a preference relation that satisfies the axioms. If we write down a preference relation that doesn't satisfy the axioms, there is no reward function that captures them in this sense. So this is the main result. So our claim is that you have two doors of interpreting the hypothesis to walk through. Otherwise, you have these 5 axioms that you can choose to disagree with. But if you say, I agree with all 7 of those, then our conclusion is you must embrace the reward hypothesis. But this gives you lots of options of ways to disagree. Before I move on to just some reflections and wrap up, any questions or comments there?
You can leave this for the discussion later, but I've been struggling with this paper and trying to wrap my head around the sort of formalism. And I think the one that I'm struggling with the most is the axiom, I think was 3, independence, right? And particularly like from a pragmatic point of view, like, you've got all these like distributional RL, you've got, CVAR, was it like from these behavioral economics literature that you mentioned, that seem to be perfectly okay with handling risks and whatnot. And I just can't put these two together. Like, what am I missing here? Sorry, you're on mute.
Yeah, thanks, Moni. I'll just leave this up so we have independence in front of us, but I want to think about your question more too. I would say anything that embraces risk sensitivity is going to violate, I shouldn't say anything. There are really soft ways to incorporate risk that can ultimately be turned back into a scalar, and you can basically just capture things here. However, many notions of risk sensitivity cannot be captured by a scalar. So there's a paper by Yoar Scalzi and Alessandro Abate that go into more detail on exactly that problem, which I think I link in a few slides. And they are going beyond the reward hypothesis as Sutton stated it, with this notion of expected cumulative discounted reward. So you can imagine there's really like a menu of reward hypotheses. And it's one reason I'm drawn to axioms is because they can reveal a kind of axes of disagreement. So if you reject independence, but you bring on the other 4 axioms, you can still basically get a coherent theory of decision-making and goal-directedness. You're just not requiring that this notion of independence also holds, which then allows for some notion of risk sensitivity. But it will change what preference relations can be captured. And since you're softening the axioms, you're actually getting a larger set, a strict superset, because you're just not requiring the axiom hold. It could still hold of your preference relation, but it doesn't have to. And so one thing I was quite excited about with this work was that it sort of suggests looking at variations of this axiom set where we just drop one axiom but keep the others and see what comes of that. So in that paper from Aumann, it's called Utility Theory Without Completeness. And Aumann puts together a way of thinking about utility maximization without the completeness axiom. And you can imagine maybe doing the same thing without independence, as say the risk-sensitive folks do, or without continuity, without transitivity. Like you can still get a theory of decisions. And so, for instance, partial orders came up before. So without completeness, you'll get things like a partial order, or this notion of Blackwell optimality from David Blackwell that I've always found super cool is a lexicographic order. So it's just a different category of ordering, and they just define different decision-making problems and reinforcement learning problems. And so I think that space is potentially really important to explore more and to better understand. So it's really is the expectation the kind of right thing for us, for our given domain? And my personal take is, in some cases, sure, but not necessarily all cases, as maybe the CVAR and the risk-sensitive folks have shown. But yeah, curious if anyone else has thoughts on that, feel free to chime in too. Excellent. Okay, so any lingering questions on the reward hypothesis before I move on to some wrap up? Okay, all right, so we're just in the last 15 minutes. So I'll just move on to these are takeaways about the reward hypothesis, and then I'll have some more general kind of holistic reflections, and then would love to dive into more discussion. So on the one hand, as we interpreted it, there is a sense in which the reward hypothesis is false, right? We can find goals, namely preference relations that fail to satisfy at least one of those axioms that cannot be translated into a reward in the sense we talked about at the beginning. The second is that, there's been this long and I think quite beautiful line of work suggesting that people regularly exhibit behavior that deviates from these sort of norms of von Neumann and Morgenstern, the axioms. So as one example, right, we have this notion of the number of options in front of you changing your preference relation. So if you're asked to pick, what are your, order these shirts from best to worst, and now order these 3 shirts from best to worst, there's evidence that people actually invert their preference in some cases when they're choosing from a large pool as opposed to a small pool. And the von Neumann and Morgenstern axioms typically would say we're violating one of the axioms in that case. And so I think there's actually, for my take, this is speculating far outside my expertise, but my take is that there's probably good evidence to suggest that in some cases people regularly violate basically all of the axioms. I mean, these are kind of a toy model of rationality for a specific notion of decision making. And so we're left with the situation that when we write down reward functions, especially in kind of designing and building artificial agents, we're writing down goals that are reflective of this implicit commitment to these so-called kind of rational preferences von Neumann and Morgenstern, but that's not necessarily the kinds of preferences that people maintain regularly. So I've written this down as a Venn diagram. Of course, I have no clue about the extent of the overlap, but my point is that these certainly aren't fully overlapping. I think that's one thing we might all agree to. And if that's the case, we might need to seriously reconsider to what extent we're conceiving of goals using this kind of language, or at least be mindful that we're making this kind of commitment. The other is to really point out the existence of these other kinds of objectives. So Mani mentioned risk sensitivity, and there's things like multi-criteria RL, which I think came up earlier on in the discussion as well. Constrained objectives, like depending on the domain, maybe one of these other notions of a goal is a better fit. In this paper, we also include this algorithm that can take as input a preference relation and output the reward that perfectly captures that preference relation. It's also an efficient algorithm. It has a massive assumption, which is that the preference relation has to be known to satisfy the 5 axioms. But this is a kind of perfect notion of reward design. Under ideal circumstances, we do have an algorithm, but it's really that those ideal circumstances are never realized in practice. So this algorithm is unfortunately not that useful for us. I'll just point to 2 papers from this line of work. The first was with my colleagues, Will Dabney, Anna Hartunyan, Mark Ho, the 2 that were here, and then Michael Lippman, Doina Prekap, and Satinder Singh. That was focused on MDPs. And then this paper I just summarized was this one with Mike Bowling, John Martin, and Will Dabney. So the suggestion for going beyond Dogma 3, the way I like to think about it is that different kind of materials are good for different kinds of buildings. So there's a photo of the Edinburgh Castle in my hometown. And if you wanted to build, a sturdy building that will last for a long time, you might use stone. But if you want to build something, beautiful and transparent for a different purpose, you might use a different material like glass. And still, if you wanted something regenerative, you might use wood. And I think the same is potentially true for a theory of goals and potentially, goal specification in the case of artificial agents as well, that we should embrace kind of a holistic view of goals, that there's lots of different ways of writing down goals. So I just want to highlight again a bunch of papers in this space that have been really, I think, informative for me, and I think folks here might really enjoy. I mentioned the 2 that I was on. There's this paper from Yoris Scalzi and Abate. The focus is explicitly on rewards not capturing multi-objective, risk-sensitive, and modal tasks. There's some work from some folks at Mila that did kind of the initial work of bringing utility theory over to MDPs. There's Tom Ringstrom's thesis, who was on the call before, if Tom's still around. So Tom has been arguing against reward for a long time and has this kind of comprehensive theory on empowerment and how to think about empowerment as maybe the more primary object. If that's a fair summary, Tom, feel free to correct me if not. And yeah, Tom is still here. Awesome. The last one is a more recent paper from Jonathan Colosso-Carr, Prakash and Doina from McGill, looking at going beyond this, settling the reward hypothesis for kind of broader classes of preferences. Okay, so the suggestion for Dogma 3 is to really recognize that there's nuance. Like reward can do a lot, but there is nuance to this picture. It's not sort of a nuance-free picture that rewards can capture everything we want. Okay, so just a few final slides to wrap up. We started from this point of asking, when we think about the ideas, research, questions, experiments, hypotheses, and so on from our science, we kind of fit them through this hole, namely our paradigm that shapes the structure of those, or perhaps we kind of have that hole in mind as we're coming up with them. And in thinking about RL, our view is that these three dogmas were really limiting and kind of creating a hole for the kinds of concepts and models and experiments that we were focused on within RL. So the hope is to relax them and really embrace this more holistic view of RL. The dogmas were environment spotlight, learning is finding a solution, and the reward hypothesis. And our suggestions are to embrace agents, to embrace learning as adaptation, and to recognize the nuance implicit in the reward hypothesis. I think in the interest of time, I will jump through this one just so we can have some more time for questions. So I'll just pause on this slide as well. A huge thank you to all of my collaborators from across. While this talk, of course, was on the three dogmas with Mark and Anna, this touched on pieces of work that were joint with all the wonderful folks you see up here. So feel deep sense of gratitude. It was a lot of fun to work with these folks, and everyone on here really contributed a lot. And so with that, I will wrap up and we can go into some questions. So thank you all for bearing with me. It was a long session, but tons of fun with the discussions. So I'm happy to dive into more. Thank you.
Could I throw out one idea that's, again, the pragmatist in me compels me to say, in the same way that I would define an agent as when something is best modeled as an agent to make my program more effective, my model of the world plus self plus other people, machines, whatever is in the model. If I label something an agent, it makes it more efficient to describe it and I get better outcomes, then I'm going to call that thing an agent. Similarly, since the dawn of civilization, people have had to figure out how to compare different things. So eventually it was bartering and later on it's money, but eventually you get a common currency, right? And in our brains, there's a currency, right? It's dopamine, best, sort of simplest single thing I could say. It's more complicated than that. Of course, this is probably related to some form of expected reward value, but that dopamine works whether we're talking about walking on the beach or eating an apple. So, and you give a great example with the large number of shirts and a small number, and you see some disparity. So we think, oh my gosh, maybe people they violate these assumptions. But I think that from my standpoint, I feel like those kind of, I don't know those studies exactly, but I could imagine, I know for me, it would probably be true that if you present things different ways, I might make different rank orderings. But I bet you there's two things that account for that, right? It's not that I don't have, like, I think it makes the most sense to me to use value and reward, but that I'm going to have proxies because my human brain is not, like over evolution, we make mistakes. And we have limited resources. The way we handle it is we have proxies for how we rank order things, and by different normalizations based on how many items are in the set, or you can come up with some disparities. So I think I could explain away, even though I don't know those studies. I imagine a careful scientist looks at those things, we will explain them away based on some proxies we use. And the second thing is you can actually imagine that the value of a shirt might be different in a different pool of shirts for some rational reason where, a more sophisticated analysis. But all this is to say that I feel like a practical approach with a common currency, I think makes the most sense to me, even though there's philosophical issues and it's complicated and there's and it's hard to build a system. Evolution didn't come up with a system that exactly does it. But I think that anyway, for what it's worth, so I like the idea of rewards in the end, but it's as much for practical reasons as it is for the philosophical reasons.
Yeah, great points. Thanks, Michael. That definitely resonates, and I can see the elegance of kind of focus, starting kind of pragmatist first, and recovering the view of goals from that. Especially with agents, I think that I definitely agree with both points to some extent. I do sympathize. I would also say being able to understand the implicit commitments that go into that view, I would say, is independently useful on its
I
own.
agree.
Okay, then I think we're probably fully in agreement because
That's a strong statement. Yeah, but yeah, sure.
yeah, yeah, maybe fully is too strong, but on this point at least, it sounds like we
Right.
definitely see eye to eye. Maybe as one comment on this, like coming back to, I think it was Monty's question of how might we think about, say, risk sensitivity, just being able to understand, well, we can peel back independence and then recover risk sensitivity. And we can carve out this landscape that says, here are the different ways we can toggle things on and off that give us different accounts of, say, goal directedness or an objective. I think that's inherently valuable.
Yes.
However, yeah. Okay. Awesome. Yeah. Thank you, Michael. Appreciate it.
Yeah, I really enjoyed this. Anyway, go ahead.
Thank you. Yeah. Any other comments or questions?
Oh,
Go ahead, Eli. I think you're muted.
Yeah, of course I was muted. I was raising my hand. I was also blurry. Anyway, I've been saving this question for quite a long time, since the middle of the presentation, but as a, I know this might go under uncertainty among those 4 forms of learning, but why not a notion of learning as the extension of dynamical timescales of control? And by control, I actually want to be a little specific computationally. I mean something like control by inverse dynamics rather than control by, forward prediction and a value function.
Really interesting question. Can I make sure I'm understanding the view? So, learning in terms of control over, I guess, the observable environment in a way.
Yes. Yes. At a variety of, dynamical timescales. The idea being, so think of PID control. If you have a system with essentially static dynamics, meaning, all the passive dynamics that might generate disturbances are basically just noise, they have no real dynamical structure, then you just, tune a PID controller and you'll basically get results. Then at the other end, once you start adding in, temporal structure to the disturbances, what we'll usually do in engineering is go straight to model predictive control and say, now let's just have a forward model that goes out to the necessary time horizon and a cost function. And then we're bringing in, notions of like learning a model, learning a model, minimizing a cost function, and already engaging in the 3 dogma, in the dogmas of reinforcement learning. What if instead we tried to turn it around and say the actual goal, is to be able to control, but at a, at some longer time scale than essentially 0.
Interesting.
Or
Okay.
to,
I think
or
almost,
to increase the amount of structure that we allow for in the disturbances that we can reject in the course of control.
right. So I have maybe 2 comments on this. One,
Actually, let me finish off with
Oh,
like
yes.
a concrete example, because I think that'll really get at what I'm thinking.
Yeah, perfect.
A good concrete example is just the old-fashioned mountain car problem. Right? So if I tell you, your job is to get up to the flag on the top of the right hill, then, we all know what that means in quote unquote cost function terms, just minimize a distance.
Mhm.
But the actual trouble is that, your system is underactuated. Or rather, it's underactuated for doing that by something like PID. Once you've learned about the slightly longer time scale, you can then just pay the cost of going left a little bit and zoom back down, and you get there. So it's actually a very simple problem. It's just a matter of knowing that you can control the system on a longer time scale by accepting the short-term disturbance. And in fact, knowing that you have to do that in order to achieve certain values of reference position or whatever.
Right. My instinct would be to label this as one of the behavioral views, in part because it's a property of meaningful behavior change. However, one way to put it is, do we need to have access to the agent's mind to understand what's going on inside the agent's mind in order to know whether learning is happening according to this view? And I can imagine a sense in which we can purely look at the behavior and then the consequences of that behavior in terms of changes in the environment to determine whether or not learning is happening. So that would be my instinct would be to put it into that second category. However, I think Tom may still be on the call, and I want to say this resonates quite a lot with my impression of your view of learning, Tom. So I don't know if you have anything you want to add here. Does this resonate with your view? It's maybe one way to put it.
I'm preparing dinner, so I'm sort of half listening.
No worries.
That's right. Yeah, but we can talk about it later, I'm sure.
Yeah, sure thing.
All right. If you guys want to loop me in on Slack or something when you end up talking about this, that'd be really terrific. Thank you.
Sure. Definitely. No, thanks for the question, Eli.
If I may, David, I'm going to ask a question that will hopefully address both Michael's sort of pragmatist concern and Eli's question. And that is really the question of, I suppose the question for you, and I think you'll see how this relates to both of those concerns, is for me, the third dogma, the reward hypothesis, is sort of equivalent to the question of where do rewards come from. And maybe that's incorrect. Maybe I shouldn't equate those two things together. But for me, and you kind of even like alluded to this, you made a quick remark about how some of that work that you did led to this algorithm that will lead you to devise the appropriate reward function, right? For me, that is the ultimate question, right? And the way and that's the pragmatic output of these sort of philosophical questions, if you want to call them that. I think ultimately they're very pragmatic, and I think the crux of the pragmatic sort of utility of these questions I hope will come out of this line of inquiry is our algorithms to devise reward functions, right? And to sort of connect it maybe more explicitly to Eli's point is that really the ultimate goal here is to come up with the reward function that will appropriately sort of regularize the time spent versus the distance reduced, right? And so yeah, if you want to just comment on that first, like what is the relationship between the question of where the rewards come from and the reward hypothesis as you sort of presented? And I feel like in my response to your paper, I kind of maybe committed the mistake of muddying the water and sort of making this equivalence between the two, where maybe these are just separate concerns.
Oh, such a good question, Moni. Thank you. Yeah, let's see. I have a couple thoughts on this. And before I dive into that, I'll just flag to everyone. So Moni's giving a talk next week on this response kind of extension of the three dogmas. So it's a beautiful paper. I definitely recommend folks come in next week to listen in for that. So I think my take is that the question of whether the reward hypothesis is valid, as stated by Sutton, can be understood separately from the question of where do rewards come from. In part because for our story of the reward hypothesis, as we outlined it, really, we just are kicking the can down the road to preferences. And then you're asking, where do preferences come from? So I think it can bring some clarity to the question, But what we're asking is, can preferences be captured by rewards? Now, where those preferences come from or where those rewards come from is potentially no worries. Thank you so much, Michael. Appreciate the questions. Where those preferences come from, I think, can be viewed as a separate question. Now, if no preferences could be captured, if reward cannot capture any preferences, then I think it has bearing on the question of where do rewards come from. And similarly, if rewards could capture every preference, it would also have bearing. So I think the two are entangled with each other, but they're not, in my mind, the same exact question. Maybe just a final comment on this. I think if we do take this preference reward equivalence, like you buy into the 5 axioms, one element of color it can give to this question of where rewards come from is, how is it that the mechanism that's producing rewards satisfies these 5 axioms? Or perhaps it's not those 5 and we give away independence or something like that. But just to summarize, yeah, I do think they can be answered independently, but they do have bearing on one another. Yeah, thanks, Moni. And if I may, actually, just one final question. I know we're at time as well, so if folks need to head off, no worries at all. It's been a lovely discussion. I can hang out for maybe another 5 or 10 minutes, so I'm happy to stick around to chat. But I just want to make sure if folks need to head out, they have a chance. The last thing I'd mention, we don't talk about this too much in the settling the reward hypothesis paper, but in the previous one on Markov reward, we mentioned Jonathan Sorg's thesis, which is on what he called the optimal reward problem. It was one of Satinder Singh's students. It was based on this paper, Where Do Rewards Come From? And the framing from Sorg's thesis, and I imagine this comes up elsewhere. I'm certainly not a neuroscientist, and as you all can tell from the way from this presentation, of course. So I apologize if I'm missing context, but my sense is that this distinction from Sorg's thesis, I really like. It's between what they call how rewards and what rewards, which is rewards that specify the task. What is it that are needed or desired by the agent? Those are the what rewards. And then there's how rewards, which are the breadcrumbs that let agents learn to find the what rewards more quickly. So things like potential-based shaping and other forms of shaping are how rewards that just accelerate learning. And in the settling the reward hypothesis work, I might need to think about this more carefully, but my immediate reaction on reflection right now is that we're primarily talking about the what rewards, like what policy orderings. There's some complexity because we're talking about history-based policies, so learning is kind of contained in the history. But I do find that distinction of what and how rewards quite illuminating, because it can mean, for say Eli's mountain car example, the how rewards might encourage the agent to move away from the flag initially to get that initial momentum. Anyway, okay, I'll pause there. Any other questions?
I just wanted to ask one more question about relating this work. First of all, I just wanted to mention how much I appreciate this work, your first principles approach and the mathematical rigor. I think this is very, very much needed in our field, so thanks for that. So the connection between rewards and the alternative approaches that exist in the field, like for example, you yourself are using this information theoretic measure of empowerment. Tom is using that. There's these alternative approaches like Danijar Hafner's action and perception as divergence minimization. Can we try to connect the reward hypothesis to those approaches, because they ultimately also give us some scalar that we might want to choose to minimize or maximize at this very high level? What do you think is the connection between these framings?
Yeah, that's a deep question. I have some initial thoughts, but that's another one I'd probably want to think about more. And we spent a little bit of time on this as part of the Markov reward work, just thinking about, say, divergence minimization and free energy and these kinds of things. Yeah, really interesting space. So one way I'd put it is that, at least as I tend to write down, as I think about rewards and say like the pure kind of mathematical version of RL, the reward doesn't have any meaning on its own until it becomes part of this optimization process, until it starts to appear inside of a maximization, and say the agent gets one burst of reward every time step. And once you write down that the objective is to maximize some function of that signal, then it suddenly takes on meaning. And so in that sense, I think I'm just going to end up pointing to things like cumulants and like generalized value functions, the GVF line of work, that say you can accumulate any scalar, and say you're in a Markovian world where state transitions occur as a function of just the last state in action. Any scalar can be received as part of that process, and it can induce its own optimization process, its own optimization problem. So in that sense, I think, like, in other words, rewards meaning takes on form once you start to try to maximize it. So the content of the reward, it could be something like this divergence minimization. It could be really any scalar that you would like. So I do think there's potential to kind of accommodate a lot of the different views. Now, maybe just a final comment, and I can maybe promise to try to talk about this in the plasticity work, but I don't have any planned slides on it for now, but maybe I can plan ahead and add a slide or two. There were a few folks that pinged me after that work about the relationship between plasticity and empowerment and free energy minimization, and suggested that there might be some deep resonance between these two things. My sense is that with, say, multi-criteria RL or multi-objective RL, where you have, say, two different signals that you're trying to balance between, or three in some Pareto frontier, it's fair to call all of those signals reward, in my view. Maybe they're just different kinds of rewards. It's the RGB channels of reward or something. And there's one version where you take a weighted average and collapse them down to a single scalar, but there's others where you like respect the differences in the channel. And then you're just choosing to not adhere to all five axioms, and that's okay. So it could be that most of the unification across these perspectives comes when we start to relax the axioms that, say, get us away from expectation, or say get us away from geometric discounting or whatever it might be. But to be fair, I'm speculating. I think there's a lot more we could do to bring these together.
Yeah, certainly not an easy task to define and make agents mathematical and then unify all of these like totally different viewpoints. So it's very exciting work. So actually, maybe my last question, maybe I should keep this for after your second talk, but what are you most excited about these days in terms of your own research? If you want to answer it, maybe like after your second presentation, or now, it's up to you, but that's what I wanted to ask you also at some point.
Oh, that's a great question. Yeah, I'm excited about a couple things. I'll maybe think about it and give you I can answer in my next one. But I was quite excited about the plasticity empowerment work. I had this other colleague, John Richens, who he's been leading this, I find, really cool line of work on when agents necessarily contain a world model implicitly. I find that line of work that he's been leading really exciting. So anyway, I think that there's a lot that's exciting me these days and keeping me occupied, I would say, but those two are the most immediate ones that come to mind.
Perfect. Thanks. Any final thoughts? Gonna stop recording right now, and